Example 3, we're supposed to find the number of terms for a geometric sequence. So again, they're telling us it's geometric. So that tells us that a sub n is our first term times some common ratio to the n minus 1. And this time, instead of giving us 2 points, they're giving us this sequence. And again, it's not just finding the formula, it's they want to know how many terms. So they gave us the first term, the second term, the third term, but they're saying this is a finite sequence and they want to know what is n. In other words, which term is the 2,187? It would be helpful if we knew what the r was. Well, given that it's geometric, we only have to check once. You might be able to tell multiplying the -1 times what would give us a +3. -3. So here times here, if we multiply by a -3, from here to here, if we multiplied by a -3, and we can also check it. The ratio equals any term divided by the term before it. We're going to get a -3. So in our formula to the left, we know not only the first term that was given to us, correct? -1, we know the common ratio, which is -3 to the n minus 1. So now we have the formula for the sequence. We have to find n. Well, we know a sub n. We know that entire term is 2,187. That's our last term in the sequence. We just want to know what's n. What number term is that? So that means we have to solve for our n. Now again, order of operations. I see too many people making the common error of multiplying the -1 by the -3 first. Remember, we can't do that. Go back to the pre-algebra stuff, which I know you know, but sometimes when we get to pre-calc and calc, we kind of forget some of the nitty-gritty fundamentals. So let's divide by that -1. So we'll get a -2,187 equals a -3 to the n minus 1. All right, so now in order for us to be able to solve this, it's an exponential. So we need to look at either seeing if we can get them into the same base or see if we can work with logarithms. Since we have negative numbers here, I would prefer to look at 2187 to see if that is some 3 to some power. Otherwise, we're going to have to play around with the signs a little bit to change it to deal with the fact that we have negatives and then working with a logarithm. So we can write 2187 as -3 to the 7th. Okay, use your calculator here. This isn't like, oh, obviously 3 to the 7th is 2187. Use your calculator, go, okay, 3 to the 5th, 3 to the 6th, or break down 2187. See how many 3's there are. So we get -3 to the n minus 1. So that tells us that if the bases are the same, then our exponents must also be equal. So we get n equals 8. If you're going to work it as a logarithm, however, we cannot use 2187 and -3, okay? We would have to use just the positive versions of both of those numbers. And I know that seems like, how can you do that? You can't divide by that negative because you got n minus 1. Don't think of it as far as us dividing by any negatives or -1s or anything like that. We are merely looking to see what number that n could be that would give us a 287. Because remember, it oscillates. We're just looking for the n. So if you put that negative in your calculator and try to take a logarithm, you're going to get an error. So if we're just looking for that n, okay, we would just consider this to find what that n is. So we could take the logarithm of the left, 2187, and then the log of the right, 3 to the n minus 1. That allows us to move that entire exponent to the front. So we would get n minus 1 equals the log of 2187 divided by the log of 3, which is actually 7. If you put it in your calculator, add 1 to both sides, and we also get n equals 8. So again, let me stress, I want you guys to pay attention. What we did on the right-hand side, we did not divide by the -1. We did not divide by the negative of the 3, otherwise the 2187 would become negative. All we did is we said, okay, we want to solve this equation. In order to get an exponent out of the exponent position, we would take the logarithm or put them in like bases. But if you saw the logarithm, it is a valid approach. But the negative bases on both sides there would cause us trouble. But if 3 to some power would give us that -3 would give us this negative number, well, that absolute value should give us the same absolute value on the other side. So we didn't do anything mathematically to get rid of those negatives. We used our analysis skills to go, but the value of n should be the same even if they were positive. Okay, that absolute value would be the same. So we're just wanting to know which term it is. And either way, we found that term to be 8. Okay, so if the logarithm part throws you off, don't worry about it. You do the like bases method on the left. And that is it. That is it. We've got one more section, folks. One more. We can do this. All right. Talk to you soon. Bye.